Hi ladies and gents, hold on to your britches because we're about to have a blast learning about the applications and working knowledge of supercritical fluid extraction. Brought to you by the 4 Extracteers. Shall we begin? So the main supercritical fluid extraction properties in play are low viscosity and density, high solubility and diffusivity, negligible surface tension. These top three play an important role in the mass transport of SFE. The low viscosity and density allows for solution-based models to be used. High solubility and diffusivity are important for the ability of the fluid to permeate into the solids, so let's say coffee beans, and we'll talk more about that later. And then negligible surface tension plays an important role in being able to transport the components through this process. And then rapid homogeneous cooling by depressurization, also known as the Joule-Thomson effect, applies whenever the fluid is loaded with a component like, say, caffeine, and then you drop the pressure to decrease the temperature as well. And then this brings the fluid back into a subcritical state, which lowers the solubility. Some main considerations using SFE are the fluid and solvent used, especially if there's a co-solvent. For the fluid, the operating conditions depend on which fluid and the fluid properties, and the critical states can be seen here as points D and Z for water and CO2 respectively. And these have very different operating conditions. And then there's also the solubility of the matrix solutes, which are byproducts, and things usually don't dissolve so neatly, like only caffeine being dissolved. There's usually other byproducts being dissolved in the matrix, and this is, or it can be, a problem that requires additional separation later in the process. Another major consideration is the operating costs of operating SFE. And so in the process, usually you're raising the temperature and the pressure, and then you drop it again, and then raises it, the pressure and temperature back up. And this is generally very energy intensive compared to other extraction methods. And on the graphs left here, you can see that with increasing temperature and pressure, the solubility of the fluid generally increases. Now, if there's a co-solvent, like say you have water and CO2 as a supercritical fluid, the ratio of them determines the solubility more so than the temperature or pressure. And the feed ratio is very important in your operating conditions and the product that you receive. Also, the vessel rating is important, especially for safety considerations. You don't want anything blowing up, and you want your vessel under high stress and pressure to be able to handle all that. And the safety considerations will be discussed in a separate video. Here is an example setup, and it's relatively simplified, and I'll walk you through it, starting from the CO2 tank reservoir. So it usually starts out as liquid CO2, and then there's a cooler to make sure it's liquid so it doesn't harm the pump. Once it flows through to the heater brings the CO2 to a supercritical state, which passes through the extractor, or a fixed bed containing, say, coffee beans. And this is largely a time-dependent process, as the caffeine loads into the supercritical fluid, and then the fluid with the load reduces in pressure through a valve or some other mechanism, and it can decrease the solubility greatly so that the caffeine load just precipitates out. And this can happen multiple times to get a better separation, or there could be another method, like say absorption filter that takes out the CO2, or not the CO2, the caffeine. And so this flow of CO2 subcritical state is then cooled back into a liquid state to go back into the reservoir, and the process is just repeated again. Comparing SFE to other methods, SFE generally has a greater equipment cost because of the more stringent ratings and higher pressures they can handle, and the higher operating costs from the energy-intensive quality of the process. And then SFE generally follows more stringent standards or codes or regulations than other methods. And they may even fall into a division 2 or 3. And then SFE, thankfully, has relatively greater selectivity for certain components like caffeine. It's more selective and doesn't have as many other components in as much quantity being dissolved in the fluid. The other extraction methods, usually using water or other organic solvents for decaffeination, might be ethyl acetate or dichloromethane. And an important consideration is the solvent costs and the disposal of solvents, because you want to be environmentally friendly and you need to not create environmental hazards. And then the solubility of these solvents make a general matrix where they don't necessarily become very selective. You have more of the other components, but it's generally cheaper in that regard as well. And then these usually follow Division 1 coding, which is a little less stringent and more general type of regulation. And here are some of the references used. Thanks for listening.